Hi everyone and welcome to this another session on the art of EDA. So this is a free webinar that we have been hosting and we will continue that and we will wait for some more time and then we are going to start off with the session. So let others join as well, then we will start this session. So those who have joined right now, we are going to wait for another 2 minutes and we will start exactly at 6:05. Hi everyone, so we are good to go. If you can hear me clearly and you can see my screen, just drop a yes in the chat box and we will start off with the session. Alright guys, so let's get started with the today's session that is on the art of EDA. So here we are going to talk about what is exploratory data analysis and why do we exactly do this exploratory data analysis. All right, and at what stage of this data science life cycle do we need to do? We will talk about the exploratory data analysis part. When do we exactly need to do that? All right, so here as we can see, we have this data science life cycle. So first of all, the life cycle starts from your business understanding, right? From your problem definition. So at first you should define your problem statement, then data, you go for data collection, then data preparation, then we do exploratory data analysis, then we go to model building and model evaluation, and then deployment. And this is a continuous process, but at every stage of this data science life cycle, you have to do something, you have to do some process. All right, you have to going to need some tools to do that. So first of all, the problem starts with business understanding. Let's say if you want to find out whether a person is going to be this COVID positive or not, for that you need a domain knowledge. You should be specialized in medicals, right? If you are not specialized, then you have to consult with the doctor, right? If you want to build a model, what all variables are necessary, what all are symptoms, right? And then you can only predict whether the person is going to have this disease or not, right? So you need to consult with the domain expertise people, or otherwise you have to do the research on your own. So at first the problem is very vague, right? You have to understand, ask question, a lot of question, right? So you have to ask a lot of question based on this problem statement. So the problem statements are very simple. Let's say I will say I have to predict something. I want to predict the sales, I want to predict the object motion in this video. All right, so these are very vague questions. You need to ask questions. You have to start asking question. What are the data, what are the variables, what is the size of the variable, right? And have you done any previous analysis of these variables? What was your sales in the previous quarter? So you need to ask so many questions, right? Then only you can proceed forward. And after asking these questions, you need to collect data. Do we have that data to solve this particular problem, right? If you don't have any data, whether you want to build this model to predict the COVID patient, whether they are going to be positive or negative, if you don't have any data at beginning, what we were having is very small data, right? What we were having is very small data, only few thousand, right? Some thousand or something. So we cannot work on that, right? So we need to identify whether do we have this data, and if we have, what kind of data do we need to solve this problem? Does the data that is there can solve our problem, or do we need to collect some extra sources of data? Do we need to merge some data here in our databases? So you have to ask all these questions, and after asking this question, then you can go for data collection. If the data that you are looking for is not there, then you have to come up with methodology to collect this data. So you can do it using this web scraping or data from databases, different data sources, and open repositories. So these are your data collection step, right? Next, moving forward, after you have collected this data, then this data is going to be a noisy data. There is going to be ambiguities in your data. There are going to be inconsistencies in your data. So you need to prepare your data. You have to remove all those noises, all those missing values that are there, or you have to identify why there are missing values, if there are any. And if there is any inconsistency, let's say in place of this null values, I have put a question mark, or I have just given a hyphen. Now what does that mean? This is a noisy data. We have to remove these noises. we have to identify all of this data processes or noises or missing values, and then we have to remove them from our data set. All right, now after you have prepared your data, then comes your exploratory data analysis. This data preparation and exploratory data analysis goes hand in hand. So you do data preparation, at the same time you go for this exploratory data analysis as well. So these two terms are interlinked and they are mostly used interchangeably, right? So most of the time if I say to you that we are going to do exploratory data analysis or data preparation, what a beginner might think is we are going to do this all the step, that is data preparation as well as data exploration. So these two goes hand in hand, and yes, these two can be combined as well. Then after you have done this exploration, now what do we look for when we explore this data analysis? Why do we need to explore it? Can't we just go and build our model and then deploy it? Why can't we do that, right? Why do you think that we need to do this exploratory data analysis in your views? Just drop a comment or just drop your views. Why do we need to do this exploratory data analysis? What in your views can be achieved by using this data exploration? Can't we just go for model building, right? That we have collected data, we have removed the noises, then just we can go for this modeling, right? Why are we going for data exploration here? So just a line of thought that you can share. So let me know, what do you think? All right, so during this exploratory data analysis, what do we actually do, right? We try to analyze our data, we try to summarize it and try to identify trends, patterns, relationship, form and test our hypothesis. But why do we need that? Why do we do that? That we are going to see in this particular session, right? So we are going to talk about all of this data exploratory data analysis. Why do we need it? How do we do it? And what are the things that we look for? All right, so we are going to talk about that. So let's move forward. And here, whenever you think of marriage, all right, whenever you think of marriage, then you think of a right partner for you, right? You do some kind of investigation before choosing your life partner, because if you don't want to end up living your rest of the life with someone whom you have not dreamed of in your wildest dream, right? So you do some kind of investigation. You try to find out his likings, dislikings, right? What is his character? What is his interest? Is he settled, right? There are so many questions that you look for when you are going to marry someone, right? You do some investigation, then only you say yes or no. So let's say, what do you think? What should be your partner like, right? So he should be smart, right? He or she should be smart, or they should have the good character, good heart, and they should have a good work-life balance, right? So all this information and all this investigation you do before marrying anyone. Same goes for your data exploratory data analysis, that is data and your models. So we are trying to build a model, and you do this investigation. We investigate our data because we want to identify whether this data is right fit for this model or algorithm that we are going to apply for, right? If here, let's say you choose the wrong partner, so you choose the wrong partner for you, then you have to spend rest of the life with that guy, right? You have to spend rest of your life with that guy, and you don't want to do that. Now, in order not to do that, or in order to avoid that, you need to do some kind of investigation, right? Behind what is his character, how he works, what are his natures, you try to find out his friends and all those stuffs. Same goes with your data as well. Now here, if you fail in your marriage here, then there is going to be loss of emotion, right? You are going to get disheartened, and you are going to get, there's going to be a mental trauma for you. Same goes with the machine learning as well. Whenever you are going to marry your data with the wrong algorithm, then there are going to be costs associated with that particular problem, right? You have your cost associated with that particular problem. You have spent a lot of time building the model, and at the end you find out that this is not the right data for this kind of modeling, right? And or other vice versa, that this data or this algorithm is not suited for my data set. So we do that to investigate and find a right combination or right model for our data. So what is the exploratory data analysis? So exploratory data analysis refers to the critical process of performing initial investigations. All right, so what we are doing here is we are performing a initial investigation. We are getting to know each other, right? We want to know our data. We want to know it well, so well that if someone asks us, it should be back on our hand here. We should be able to tell it. We should be able to tell a story about it, not just a line. We should be able to tell a story about it. So this is why we do this exploratory data analysis. If you know your data, then obviously you are going to marry it with a right algorithm here, right? So to spot anomalies, if there is any anomalies in our data or outlier or missing values or inconsistency, we test hypothesis, whatever assumption that we are having about this data set, whether it is statistically significant or not. We try to summarize and analyze our data using this exploratory data analysis through graphical and statistical methods. So this is what exploratory data analysis is in short. All right, now let's move forward. Let's talk about the objective of EDA. All right, so here the objective can be listed in these 4 bullet points mainly. So we try to discover patterns. So we try to find any relationship in our data set or any kind of pattern that data can tell us. All right, so we try to discover these patterns. Then we try to spot anomalies. If there are any outliers in our data set, if there is inconsistency, if there is some missing values, we try to remove them or try to fill them. Then we try to frame our hypothesis. Now if you don't know your data, how are you going to frame your hypothesis or KPIs, right? So you need to know your data first, then only we can build this hypothesis and check our assumptions as well. So this is the objective of exploratory data analysis, that is discover patterns, spot anomalies, and frame hypothesis and check our assumptions. Now what do we look for when we perform EDA? What do we exactly look for? So here you can see that I have listed so many points, right? And there are a lot more things that we do while going for this exploratory data analysis. All right, and we will see that. So here, first of all, whenever we go for this exploratory data analysis or any data related work, what we do is we try to know the data first, right? You try to ask this question, that what kind of data do we require to solve this problem, right? What are the variables that we require? What are the data types that we require, right? So you try to check the type of the data at hand. Now what is the size of this data set, right? So how large is the data set? Do we have sufficient data to start working or solving this problem, or do we need to collect some more data? Now, what are the features of our data? So here, you need to have a domain knowledge to solve this particular problem that is at hand, or you have to research about it. Let's say, I think many of you have heard about this iris dataset, right? Now, if you see in iris dataset, we have only this 4 features, and we have 3 classes of iris, that is iris setosa, iris virginica, iris versicolor, and the 4 features that we talked about are sepal length, sepal width, petal length, petal width, right? Just to explain you better, I'm going to close this. I'm going back to this iris. Here, as you can see, we have this iris data set where we have this sepal length, sepal width, petal length, petal width, and different species. All right. So why do we only have these 4 features here? This has been collected by some biologist. All right. So why do you think he collected this many features only? That is only 4 features, and we have this species, 3 species. And now if you go to Google and just write iris species and run it, and then check for this images here, all right, and you see you have these pictures here. So we have this picture here where we have iris versicolor, iris setosa, iris virginica. There are so many features that we could have extracted from this image, right? But we choose only the sepal length, sepal width, petal length, and petal width. Why do you think so? What was the reason behind it? And this data set was collected by a biologist, and since then we have been using this data set. So as you can see here, we have this sepal, we have petal, then there are different colors, right? There are different colors and different shapes if you think about it. Then there are stems, leaves, all those features. Why only these 4 features? Why do you think so? Why only the 4 features? Because the biologist has the domain knowledge. All right, he tried out with all the features. Firstly, he would have tried out with all the features, and then after doing this, all the exploration and all the analysis, he would have been able to identify the species just by the use of these 4 features. All right, so by use of these 4 features, he was able to separate these classes more efficiently. All right, so he discarded all the features that were there. So if you think about this iris and think about this in different manner, why do we collected it at the first place, right? And who collected it? There are so many questions that you can frame and get answer for, and that will solve your doubt about this exploratory data analysis. Why only 4 features when there are so many other things that we could have extracted from here, right? So here this biologist did his exploration, did his research, and then he was able to identify these classes using just this sepal length, sepal width, petal length, and petal width, and he discarded all other features. So this is your example, a simple example of this exploratory data analysis and your domain knowledge. All right, so let's head back. So if you don't have any domain knowledge, then you should ask the people who have the domain knowledge, or you should ask or research about it over the internet or somewhere. All right, so what do we look for when we perform EDA? So we look for type of data at hand, size of data, what are the features of our data, what are independent and dependent variables. All right, so here we are going to have these variables, different variables. So we have talked about features, right? We need to know what are the features, and then we need to know what are the data types of that feature. Is it a categorical or numerical variable? Then only we can do something about it, right? Then we look for what are our independent features and our dependent feature. Is there just one independent and dependent variables, or there are many independent, just one dependent variable, or there are many independent and many dependent variables, right? So we try to find that. Then we try to look for the challenges possessed by this data, like missing values, outliers. These are some of the challenges that is possessed by any data set. All right, then you try to look the distribution of feature. Let's say if someone sells you this house, then you try to look for what is the age of the house. How are you going to look for this age? Or so let's say some person, you want to predict whether he is going to have this disease or not, right? Then you are going to look for this distribution of his age and all the distribution of all the people that has been affected by this disease, and then you can come up with some inference that if you are older, then there is a chance that you might get this disease, right? Then you try to find out the relationship among different variables. So let's say whether the age is related with this, whether I'm going to test positive or negative, whether it is related with the age. So we try to identify all this, and we try to identify the important features and discard the features that are not necessary for us, like this biologist did in case of iris species. He was just able to classify using this four variables. So we have to do the same thing. You have to discard any variable that does not adds any value in your model, right? So you have to discard that particular variable. Then we try to look for patterns, then we check assumption, then test hypothesis. So we try to check some assumption that is possessed by particular algorithm. And also then we look to visualize or try to access this assumption through the visual graphs and statistical this models. We try to prove this assumption and hypothesis. So let's move forward, and there are a lot more things that we do during this EDA. Now let's talk about the methods of exploratory data analysis. So what are the methods for this exploratory data analysis? So we have univariate analysis, bivariate analysis, and multivariate analysis. Now what do we mean by univariate analysis? If you are doing analysis based on a single variable or single feature, let's say if you are analyzing only the age and not any other variable, then this becomes your univariate data analysis. All right, and we have this bar chart, pie charts, histogram, and box plots, etc. for this univariate analysis. Then we have something called as bivariate. Now bi means two, right? So we have whenever you compare these two variables, then you are doing your bivariate data analysis, and it is used to find the relation between these two variables with respect to your target variable. All right, and we can use scatter plot, multiple bar charts, and heat maps, extract heat maps to do that. All right, then there is something called as multivariate. So whenever you have more than two variables, or you are analyzing more than two variables, then this is your multivariate exploratory data analysis, and we can use pair plots, heat maps, multiple bar charts, multiple line graphs, and multiple box plot to do that. All right, so So this is your method for exploratory data analysis. Now, I had asked you about what will happen if we directly jump to building our model instead of going to this exploratory data analysis, right? So we had asked about this, and now let's talk about what will happen. So here you are investing your time and money in this building your model, right? You are going to, after building your model, you come to know that this is the inaccurate model for this data set. There are many ambiguities in your data that we need to correct, right? So at that time you are going to feel sad and stressed, right? You have invested so much time and so much money. Now you are going to get frustrated and feel, not going to feel so good, right? So here, this, when you don't perform this exploratory data analysis, then your model is going to give you inaccurate results. Then you are going to choose the wrong variables to build your model, or either you are going to choose all of the variables that is there in your model, right? And we say that if you put the garbage inside your model, then you are going to get the garbage outside of this model as well. So garbage in, garbage out. We should not throw the garbage in our model. We should only give the features that are necessary to identify this, or identify this prediction, or make some prediction. All right, then insufficient use of resources, including rebuilding the model. So yeah, you have to rebuild and do all the part again, right? And you have used some resources as well, right? So you have wasted all those resources on, we have to rebuild our model, and this is going to be a time consuming as well, right? So yeah, this is not a right choice to skip this exploratory data analysis part. It is a very, very, very bad idea if you ever think of this. All right, now we have talked about this exploratory data analysis. Now we are going to work with and perform it in our Jupyter notebook. So again, here we'll be using collaboratory because that is easy to access and everyone has access to that. All you have to do is you have to have a good internet connection and you can work with that. All right, so if you have any doubts, you can ask that, paste that doubt in the comment box. And now we are going to Google Collaboratory. All right, so just write Collab on Google and enter. All right, and click on this first link, that is Google Collab. So let's go on Google Collab. All right, so I'm going to get a new notebook here. So click on new notebook and we are going to work with the same data set. So if you have attended the first webinar on machine learning that we conducted, that was on building and deploying your logistic regression model, then you might have come across this data set. So we will be using the Titanic data set and we are going to analyze that. All right, so here let me zoom in a bit. Let's change the name of our notebook. So I'm going to write exploratory EDA. So just EDA, and this one is webinar. All right, now let's connect it. All right, I hope you guys are familiar with Matplotlib, Seaborn, Pandas and NumPy. So we will be using these 4 libraries only and we will do the data exploration using these 4 libraries only. All right, so there are many good visualization tools that is provided by Python, if you go here and just write your Seaborn documentation, and if you go and check that the official documentation of this Seaborn package, there are many good visuals and packages that you can utilize from this Seaborn package. So it is built on top of matplotlib, right? And this provides you with some statistical graphs as well. So we are going to use this Seaborn package, and if you see, you can read about all the introduction, then release notes, then you can read about this tutorial, categorical distribution, regression, and multiples and whatnot. Everything has been provided on their official documentation. If you want to know more about this and want to eagerly learn this, then I would suggest that you go to their official documentation page and learn from there. All right, if you go to tutorial here, if I click on tutorial, and here you have all the necessary graphs and all the tutorials available for you. So here we have this line plot, so you can read about this, visualizing statistical relationship, then relating variables with scatter plots, emphasize continuity with line plots, then you have bar plots, right? You have multi-plot grids, then there are different kind of graphs that we can utilize using this package, and they're really beautiful and nice and easy to implement. So if I go to gallery, if I show you some graphs here, all right, so you can see all these galleries. If I click on something, so let's say I click on this heat map, and here you'll get this example how to use this heat map. All right, so you have been provided the code already, you have been provided the tutorial already, so you can go and read about all these graphs and techniques, packages that are there in this Seaborn library here. All right, so let's move to our Jupyter notebook, and here first of all we have to import the packages. So import packages. All right, so we are going to import pandas as PD. Then here we are going to need this for performing our data analysis. We are also going to need NumPy for numeric computation. All right, so this is a numeric Python, so it performs vectorized operation, it performs your scientific operation, and there are many mathematical operations that we can use using this NumPy here. All right, now let's import Seaborn. So I'm going to import Seaborn. We have seen this Seaborn package as SNS. Then just import the matplotlib.pyplot as PLT. All right, so we are going to use this pandas, NumPy, Seaborn, and matplotlib. So these 4 libraries here. Now to run it, just press shift enter, and we have this imported this pandas, NumPy, Seaborn, matplotlib here. All right, next step will be to read our data. So we are going to read our data. So here I'm going to write data equals to pd dot read underscore csv, and here we have to give the path of our folder. So to get the path, just click on folder icon here. So just click on folder icon, then mount your drive. So mount your drive here and connect to Google Drive. It is going to take a bit of time, and here we have this drive option. So just click on this drive, then go to my drive, all right, and choose the folder where you have stored your data set. So I have stored my data set. I'm going to use it from our first session that was on building and deploying our logistic regression model. So here it is, titanic.csv. Just copy it. So right click and copy path. All right. And here I'm going to close this and paste our path here. All right. Now let's run this. Alright guys, so we have read our data. Now before moving forward, or before even moving to your Jupyter notebook, you should know your data set well. Alright, what are your features and all those stuffs. So you have to prepare a data dictionary for that. Let's say here we are using this Titanic data set. Alright, so here I have taken this data set from Kaggle. So if I go to Titanic Kaggle and read about this data set, so let's go to this data set here. Let's click on machine learning from disaster, that is Titanic. All right, so here you can read about this overview. So here, what is the problem statement, what you exactly need to do here. So you can read about all this. All right, and here let's say I want to know what are the features and what is the size of my data set. So here let's go up and I will go to data section here, and here I have the information about this data set. All right, so here if you see, they have already provided this data dictionary, but in real world scenario you are not going to get this data dictionary. In that case, what you will do, right? In previous session we had scraped the data from real estate website and we didn't have this data dictionary for us, right? So we need to prepare the data dictionary for that. You have to prepare what are the variables, what are the features, what are the values in that feature, what is the data type of that feature. If you talk about me, and I'm going to show you to you here, so I will go to my GitHub. All right, and just go to, just a second, I'm going to show you how you prepare your data dictionary. So here if you see, you have been already provided this data dictionary, right? So you have this variable that is survival, and here the value you have inside this variable is 0, that means no, and 1, that is equals to yes. All right, then you have this P class. So what is this P class, right? So this is the ticket class, right? So you have this ticket class, and here 1 is given if the ticket class is first class, and 2 is given if the ticket class is second class, and 3 is given if the ticket class is third class. So you can download this data directly from Google, this Kaggle. So just go to Kaggle and type this Titanic data set and you will get this data set. All right, so here then we have this column which is gender, right? So here it is given gender, then you have age. So in age you have age this in years. All right, then you have sib-sp, then this is your another variable. And what does this sib-sp mean? So sib-sp means number of siblings or spouses aboard the Titanic. So number of siblings, if there are any with you aboard this Titanic. All right, then you have this parts. Now what is parts? Parts is number of parents, children aboard the Titanic. All right, so this is your maybe the family size or your how many you know, if you have traveling with your parents, then whether both the parents, or if you are traveling with your child, whether you have one child, two child, so all those information is present inside this parts variable. Then we have this ticket, and this ticket is nothing but our ticket number. Then you have this fare, so fare is the passenger fare. And then there is cabin, so you have another variable that is cabin, and here you have cabin number. All right, then you have embark, and this is your port of embarkation. All right, from where you embark this Titanic. Is it Cherbourg or Queenstown or Southampton? So you have this data dictionary over here that you can refer, right? So you have to prepare this data dictionary. For example, let's say if I go here, I go to, all right. All right, so here I had built this web scraper to collect this data. All right, so after collecting the data, I prepared a data dictionary here. So here how your data dictionary looks here. All right, so let me open this. All right, so here if you see, it has data dictionary for schools in Karnataka. All right, so here you have this all information about our data set. So I have added all the information. That is, our data set has 39 columns and these many rows. All right, then I have given a description of each rows. So here we have column name and we have description. So we have this column name, which is instruction medium. Then I have added the language of content delivery as its description. Then you have male teacher and the description here. Then you have pre-primary section available. Then you have the description here. All right, so like this you have to prepare a data dictionary for all the variables or columns that are there in your data set. Then only you will know what kind of data you have, what kind of analysis we need to do, right? All right, so this is your data dictionary preparation after you have got your data. All right, so let's head back, and we have seen this data dictionary. Now we know what does this variables mean, right? Now we can start off with something. So here I have imported this data. Now let's check the head of this data. So all right, so here I'm going to write data dot head, and if you write data dot head, by default you are going to get 5 rows and all your features here. All right, and if you want some other, let's say 10 rows, then you can give here inside these braces, you can give 10, 20, 30, right? So here let's see only the 5. All right, so let's go up. And here you can have this view of data. So we have passenger ID, then we have survived, then we have P class, then we have the name. So what is the P class? We have seen it, right? This is passenger class, whether it is class 3rd or 1st or 2nd. All right, then we have the sex, that is whether he is male or female, whether the passenger aboard Titanic is male or female. Given its name, we have its age, we have SIB-SP. So what is SIB-SP? This is number of sibling or spouse on board aboard Titanic, right? And then you have this parts, so number of children or parents. Then you have ticket, so this ticket is nothing but the ticket number. Then we have this fare, so what is the fare amount? Then you have cabin, right? So you have different kind of cabin, C and something. Then you have embark, so from where this passenger embarked his journey, whether it was Southampton or it was Cherbourg or it was Queenstown, right? So you know all these features of your data, and you also know what kind of data is stored inside these variables, right? So now we can move forward. Now I want to know what is the size of this data. What is the size of this data set, right? So here I can write data dot size. So let's check the size of this data. Let me get some. Yes, it will be available on our YouTube channel, so you can access this later as well. No worries with that. So here we have the check the size of this data or the shape of the data. Now to check the shape, you can write data dot shape, and if you run this, it will tell you how many rows and how many columns are there in your data set. So we have 891 rows and 12 columns in our data set. All right. So now if you want to see all the columns, what you can do is you can write, so check column names. Here we can write data dot columns, and it will give you all the columns of this data set. All right. So we have this passenger ID, right? We have survived, we have P class, we have name, we have this gender, then age, then SIB SP, and all these variables. All right. So now we have prepared our data dictionary. We have checked the size of our data. We know what are the variables or columns. Sometimes we refer this as features as well, right? So don't get confused with the names. These all means the columns of this data here. All right. So now we know our data a bit. So we know the size, we know the features, and now next task will be to get some information regarding this data here. All right. So here what we are going to do is we are going to check the information. By information, I mean what is the data type in this survived column, what is the data type in this age column, what is the data type in this ticket column, right? If we know, then only we can do something or plot some graphs, right? So here what we can do is we can give data dot info, and here if we run this, we are going to get this information regarding our data here. All right. So here you get all the information regarding your data set. So here it says class is pandas.core.data frame. All right. So this is a data frame, pandas data frame, and this range index is from 0 to 890, and you have total of 12 columns in your data set. And here you can see the data type, right? Here you have the column, then here you can see the data type, and we can also see the non-null count here. So let's go down, and here as we can see, this passenger ID is int64 type, and survived here is int64 as well. But if you see here, this name is object, right? And here ticket is object, fare is floating point. So you have to identify this data type in order to be able to explore your data even further by using some visual graphs. All right. Then here you can also check the memory size, and here this data D types gives all the types of data that is present inside this data set. So we have float 64, int 64. So here we have float 64, 2 features, int 64, our 5 features, and object, our 5 features. All right. Now let's move forward, and here you need to know what are your independent and dependent variables, right? So here, what is the independent variable? So independent variables are the variables that we use to do some prediction, and your dependent variable is going to be the target variable here, the thing that you are trying to predict. So here we want to predict whether the person aboard Titanic is going to survive or not. So this is your target variable, and you are going to perform your analysis in regards with this target variable, that is survive, and all the other features that you see here are your independent variables. All right, so these, by using all these variables, we have to predict whether that person is going to survive this Titanic disaster or not. All right, so we cannot feed all these variables in its raw form, right? We need to identify the important variables or important patterns, and if this adds some values in predicting our this class, that's it, survived class, then we are going to keep that variable. Otherwise we are going to discard that variable, because that is a garbage only. We cannot feed garbage in our model. All right, so now we have seen this basic information. All right, now let's move forward, and here I'm going to tell you about some other stuffs that we do. So here you want to check the null values, if there are any null values in your data set. So here, to check the null values, let's check the null values. You can use this pandas, as well as you can also visualize this using heat maps by using this Seaborn package. All right, so we are going to see both of these techniques, and we will talk about what are the usefulness of each one over the other. All right, so here I'm going to write data dot is null dot sum. All right, so here if I just give data dot is null, I will have this values here, that is I'm getting true and false only. Why? Because if I write data dot is null, it is going to return me a boolean value, and here you have this false, that means it is not null. Here again you have false, and if you see in cabin here it gives you true, but I don't want this true and false. This is adding no values to us, right? So here I want the sum. I want the sum of null values in each column. All right, so we want the sum of null values in each column. To do that, I will write dot sum here, and if I run it, then I will have this sum of null values in each column over here. So here we can see that in passenger ID, survived, P class and name, then sex, we don't have any null values. We are having this null values in our age, right? Then we have null values in our cabin. Then we have this null value in embarked. All right, so we have to do something with that. Either we can fill it with something, or we can drop these features from our data set, and we will talk about that, when to drop this feature and when to add this or keep this and fill it with something. All right, so you have checked this null values. So there are some null values, and we have to come up with something to fill this null values here. Now let's move forward. Let me get some new code cells. All right, now let's check the description of this data. Description of our data set. So here, to check the description, you can write data dot describe. All right, so you can write data dot describe, and here if I run this, I'm going to get the description about the numerical or int and float data type only, we are not going to get the information for our categorical variables. And here if you see, we have got this count, right? We have mean and we have standard deviation, then we have minimum, 25 percentile, 50 percentile, 75 percentile, then we have this maximum. And here these are our columns, that is passenger ID. In passenger ID, and this is our survived, this is our P class, this is our age. So in our age, these many values are there, that is 714, because there are some null values. So total count is here, we are having it as 714. Then it gives you this mean here, right? So you have mean age, that comes out to be 29.69. So here somewhere around 30. So those who were on aboard Titanic were of this mean age, or the average age was this 30 years of age. And you have standard deviation, that is 14.52. Then the minimum is 0.42, right? So here the minimum age of the passenger that was aboard this Titanic was 0.42, and this 0.42, that means there was a baby as well of this 4 or 5 months, right? And then you have this 25 percentile, 50 percentile, 75 percentile, and then you have this maximum. So here you have this, in 25% of the passenger were having the age between 0.42 to 20, right? And then you have this 50% of passenger were between 0.42 to 28. Then 75% of the passengers were 0.42 to 38 years of age. And here if you see, the maximum is way larger than your 75 percentile here, right? So you have some old people as well, and there are very few old people. All right, similarly you can look this for fair as well, and then you have to write your interpretation here. All right, so there are so many things that we can interpret from just writing this data.describe. But here if you see, we have to inspect it manually. We can also draw bar graphs, all right, different graphs and visual methods. We can use visual methods to get this information, so we can use that. All right, and here we are not getting the information for our categorical variables. Now to get the information for our categorical variables, here you can give include equals to all, and if you run this, you are going to get the information for this categorical variables as well. So here we are having this information for name, right? Then also this P class, then cabin, then embark, and here if you see, we have got this information that says, go up, yeah, here it says count, then you have unique. All right, so this is the number of unique values in that particular column. Then you have top count. What is the top count in that particular column? So here if you see, in this gender or sex, this is male, so here most values are male. Then you have the frequency. All right, so what is the frequency of this top count? So here it is 577. So there are so much things that we can interpret just by writing one line of code. So here it is not about writing the code and drawing all this visual, rather it is interpreting. What do you interpret from this graphs that you draw and the text that you use here? All right, now we have different values in our columns in our data set, right? We have passenger ID, survived, P class. How do we form this hypothesis, or how do we form our question? What question do we need to ask? All right, so how do we do that? So here what I generally use is using this mind maps, where you write down all your question all right? You write down all your question that is in the back of your mind that you might think might help, to discover anything or find any useful patterns, and you list down all the question. You select the important question that according to you, top 10 first of all, or top 50 if you are having a big data set, that list down all the question that you have, then take the top question, priority question, all right, and try to follow that. So here I will talk about this mind maps. So I'm going to go to Lucid chart, and you will see that by using this mind maps, it is a great way to start exploring, formulate your hypothesis, and ask the question to your data set. So go to documents here. All right, so just a second. All right, so here it is. So I have talked about this data definition, right? Here I had my data definition, and after building this data definition, I tried to build this mind map where I ask lot of question and prepare a mind map for myself what I'm going to ask my data. So I will have a better understanding, right, what exactly I need to do. So here if you see, we have this mind map, and here in middle we have the main question. So I have kept my main question here. Let me zoom in and make it a full screen so you will be able to see it. So yeah, so here if you see, we are asking this question, what is a good school? So here our task was to find a rule, define a rule to identify this good school. Now to identify a good school, we need to set some rules here, right? So here we try to find out, we divided this task into subtasks. So we wanted to find out what is the management type, what is the school type, then what is the school age, what is the infrastructure of that school, what is the, whether this school performs co-curricular activities, whether there is any participation in co-curricular activities, then what is the teaching medium in that particular school. All right, and here after preparing this subset of this question, right, and then again we try to build another set of question on this management. So here if you are able to see it, let me go up. All right, so here we are asking this question for management. Now school with transport facility are good schools. Schools with more than 2 headmasters are better than just 1 headmaster, and this all comes into this management part, right? Then we are asking all this question based on all these different variables. So it's always a good practice if you write down all your question, prepare this mind map or flow chart or anything, you just simply write down just your question, then you are going to have a better way to approach this problem set, and you won't spend your time here and there. So this is what I generally suggest to prepare a mind map, list down all the questions that you are going to ask to your data set. All right, so let me close this. Let's head back to our notebook, and here if you see, our main task is, our main class here is this survived, whether the person survived or not here, right? So here the main question is whether this person is going to survive or not. Then I can ask so many questions here, right? I can form so many questions. Here the first question that I can think of is, what is the number of people that has survived and that has not survived that were aboard this Titanic? This is the first basic question that comes in your mind, right? After seeing this data, then you might ask, then what is the percentage of people what is the chances that if I am male or female that I'm going to survive, right? So whether if I am female I have the more chance to survive, or whether if I am male I have more chance to survive, right? Then you have this age. So where the person, old age person has a more chance to survive, or a child has the more chance to survive, or a girl child has the more chance to survive, right? Or whether the adult has more chance to survive. So there are so many questions that we can form here, right? Then you have this C base P. Then if I have the large number of greater number of C base P, let's say 4 5, then is there a more chance of me surviving this disaster, right? So there are so many questions that you can form based on this embarked. Then you have this fair, right? There are so many questions. So you list down all the question first, then try to approach this data set. So this should be your approach here. All right, so I have given you an intuition, right? We are going to solve some of the question. We cannot solve all the question in just 2 hours. It is going to take some time, but I'm going to give you an understanding of how you do that. All right, let's move forward now. So here, now first of all, we have to fill this missing values here, right? So we have some missing values in our age, then we have some missing values in our cabin, then we have some missing value in our embark here, right? And here if you see, in cabin there are 687 missing values here, right? And the total number of data points that we have, or rows that we have in our data set, is 891. So here more number of datas are having this null values, so it does not add any value, right? As there are most of the values are null only. We are not getting any information from this cabin. Then if you go to this age, then we have 177 missing values. Now this is very less. We have to come up with something, either mean, median, mode, or some other method to fill this missing values, right? And here you have some embark. All right, so there are only 2 missing values. You can simply fill them or drop them as you wish here. Now let's try to find if there is any pattern in this missing value. Now to check the pattern in this missing value, we are going to use heat map. All right, so we are going to use this heat map here. So here I'm going to write SNS dot heat map, and here I'm going to give data dot is null. All right, and here if I run this, let me run this. Here if you see, we are getting a heat map for this null values. All right, so whenever you see a null values, it is going to be in light color. All right, so whenever you have this missing values, it is going to be light color. So here as we can see, in cabin most of our values are having null counts. So most of our values have null. It doesn't add any sense or any meaning, right? So it is just a garbage. We have to get rid of this garbage here. Then if you see, in age there is no particular pattern here, right? So we have to fill this age, and then we have some missing values in embark, but it is not visible here as there are only 2 missing values. So we are going to drop this cabin. We are going to get rid of cabin. And also if you see, this passenger ID does not add any value as well. Why? Because if you check this passenger ID, this is just a serial number here, right? These are just indexes, that is 1 2 3 4 5. It does not help us to predict whether a person aboard Titanic is going to survive or not, right? So we have identified these 2 variables that we are going to get rid of, that is passenger ID and then we have identified this fare. All right, and also if I talk about this ticket here, what do you think? According to you, this ticket is going to help us identify whether a person is going to survive or not. So by using this ticket, it does not add any value as well, because every ticket is going to have a unique ticket ID, right? And here, just by looking at the ticket ID, we cannot say whether that person is going to survive or not. So till now we have identified this 3 variables, right? So we have identified this 3 variables here that we are going to read of. Now let's say this is our name. Now my name is Manvendra. Then can you predict whether I am going to survive this Titanic or not, this disaster or not? Your name is something, right, X. Then can you say or predict whether you are going to survive this Titanic or not, right? So here we cannot predict by using this name here. So we are going to get rid of this name as well. So till now, how many features we have identified to get rid of? That is name, then our survived, then our cabin, right, then our ticket, right? So we are going to get rid of these 4 features. Now to drop them, so let's drop them. So drop, so we are going to drop unwanted features, and here to do that I'm going to write data dot drop, and here I'm going to pass a list. All right, so first of all we are going to delete this passenger ID. All right, so I think it's ID. Then we are going to get rid of ticket. All right, then we are going to get rid of this name, right? Then the other variable that we have identified was, let me check that. So we have passenger ID, then name, then ticket. What was the other one? Yeah, cabin. So we are going to get rid of this cabin here as well. All right, and now here I have to specify the axis as well. So axis, you have to specify this axis. So here 1 means this column, if you give 0, then it is going to consider your rows. So we want to drop these columns here. That's why we have given this axis equals to 1, and in place equals to true to reflect these changes in our original data set. All right, so let's run this. So I think we have misspelled something here. Yeah, cabin. So it's cabin. Now let's run this. All right, so now if we check your data dot head, we don't have these features anymore, right? So we don't have this feature that is survived, all those features, that is cabin, then passenger ID, then ticket and name here. All right, now let's try to fill the missing values. So here I'm going to write data age. All right, so data age dot describe dot t. All right, so we have this count, then we have mean, then standard deviation, right? And then if you see here, it is 28 and the mean is 29. So we will fill this simply just by mean. All right, so if you want to fill it with some other value, you have to do some analysis for that as well, and here it is going to take time for that. So we are going to fill this missing values in age with the mean value here. All right, and here let's talk about what we are going to fill with embarked class, the missing values in embarked class with. So here if this is a categorical value, right? So I am going to get the value counts of each categories here, and we are going to fill it with the count which has maximum count, the category which has maximum count, which is S. All right, so let's fill our missing values. So fill the missing values. All right, and here I'm going to write data dot fill NA, and here I'm going to give this feature name. All right, so first of all age, and here we are going to fill this age with data age dot mean, comma, next we are going to fill this embarked. So embarked, and here it is going to be data embarked dot mode. You can do that, or simply we are going to give this as S. All right, and here as well you have to specify the X is equals to 1. All right, and if you run this, all right, so by default it takes X is 1. We don't have to specify this, and we have to give in place equals to true. All right, and now if you go up and run this data.isNull, check your null values. So let's run it, and if you check your null values, there are no null values, so we are good to go. Now think of some question what you can ask. So we have talked about how to frame this question here, right? So first of all, first stage is to frame those question, and the next step is to start visualizing or using statistics, either descriptive or inferential, to do your exploration and sorry, to get the feel of your data here. All right, so here we are going to use the visual method to get all the answer for all the question that we are going to ask. So the first question we may ask is what is the count of people survived and died aboard Titanic. All right, and to do that, all you have to do is we are going to use this Seaborn package. So we have to write SNS dot count plot. All right, so it is going to give you the count with the bars, and here I'm going to give data, and here it is going to be my survived. All right, and if I run this, here we are getting this count of male and female. So I have to zoom out a bit. All right, so here you see that we have this survived. Here blue one is we have 0 and 1 class. So 1 is for female and 0 is for male. So here you can see that the number of males aboard this Titanic are more than the females, right? So you can know that by using this count plot. Next question that you might ask is who has the better chance? So we have talked about this univariate analysis and bivariate multivariate analysis. So first step is to do the univariate analysis. So this is a univariate analysis where we are just performing this analysis based on this single feature, that is survived, and you have to do this for all the features that you have in your data set. All right, so you have to do it for P class, for this sex, then for age, SIP, parts, pair, embarked. You have to do this analysis, that is univariate, bivariate and multivariate, on all these features. So we are going to talk about some of these features So here we have seen how we can explore the categorical values using this count plot, right? So we are getting this bars, and here this bar specify this height, and here if you see on x-axis we have this classes, that is categories either 0 or either 1, and here you have this count. All right, and here to add the title you can write plt dot title, and here you can give this title as count of passenger aboard Titanic. All right, and now if you run this, so you are going to get this title here as well. All right, so here you have this survived class. So if you see, more number of people have died and there are less number of people who have survived here. Now let's move forward and explore some other variables. So we have seen this categorical. Now we want to explore this numeric variable. So we have this age, and age is a continuous value, right? Now we can use this histograms to do this analysis on the age. First of all, I want to check what is the distribution of this age, right? So we want to get to know the different age groups that are there on board this Titanic. So we are going to use this histogram. So SNS dot hist. So I'm going to use mostly this Seaborn package here. So SNS dot hist, and here your variable. So we are going to give this age here. So age, and now you can add the title here as well. Let's run it. So second, I have made a mistake here. You don't plot this hist, but in Seaborn we plot this dist plot. So if you go for PLT or matplotlib, you can use this plt dot hist here, but here we are using this Seaborn package, so we have to write sns dot dist plot, and here we are going to get data inside this braces, data and our feature, that is age. And now if we run this, you see the distribution of your age of the passenger that were aboard this Titanic. So here if you see, this is starting from 0, right, and it is going all the way till 80, and if you see above this 60 there are only few people, right? And here if you see the distribution, you are able to see the distribution as well of this age here. All right, so here we have this all the distribution, and most of the distribution, if you see, most of the people that were aboard this Titanic were between age group of this 17 to this 40 years of age, right? And there are some old people as well. So let's move ahead. So this is your univariate data analysis, where you explore just the single variables. All right, so you have to do this for all other variables. Let's say if I want to know the count of males and females that were aboard this Titanic, so here you have to use this count plot, or you can use this bar chart for that. All right, so here I'm going to write SNS dot count plot. All right, here you have to give data and your variable name. So here we are going to get the count of males and females aboard this Titanic. All right, so let's run this and see. So here if you see, on x-axis we have this sex, and on y-axis we have the count here. So here it is blue one. This blue bar is for male and this orange bar is for female, right? So here if you see, there are more number of males and less number of females aboard this Titanic. And if you want to identify from this by seeing this visual, you might ask, there are more number of males, so is there a more chance that male will be saved as there are more number of males, or is there a chance that female will survive, has a more chance of survival, right? So you can ask this, frame this question, frame this hypothesis that female has more chance of survival or male has more chance of survival, and you can test that as well, right? So here we have done this univariate analysis. Now also you can use the box plot for this univariate analysis. All right, so here this box plot, so first of all let's draw this box plot, then I'm going to tell you what does this box plot tells you. So here I'm going to write SNS dot box plot, and here we are going to plot this pair, let's say, so data, and here we are going to box plot our pair. All right, let's run this, and here by default it is on y-axis, so let me give this y equals to data. Yeah, now it will look fine. All right, so here this is your box plot. It is not more visible to explain that, so I'm going to change this variable to age so I can explain everything about this box plot here. All right, now it looks good here. All right, so you see this, we have a box, right? Then there are some lines, then there are some points. Now what does this lines, these points, and all this information that has been shown on this graph means, right? If I take it to someone who doesn't know anything, it will be very hard for them to tell anything from this box plot, right? So you need to have some technical knowledge about this box plot. So here this box plot tells you about this distribution of your data as well. You can find whether your data is skewed or not. You can find whether your data has some outliers or not. All right, and here if you see this box plot, so here this point here is known as your quartile 3. This one here is your quartile, and here this one is your this one here is your median. All right, so this one you can think of this as your median. This is Q3, Q2, right? And this is your IQR. This box that you see here is your IQR, and then you have this whiskers. All right, so this is your whiskers, and whiskers are going to be 1.5 plus minus your quartile Q3 and your quartile is Q2. All right, so this is going to be plus minus 1.5. The line that you see here, these are called as whiskers, and anything beyond this whiskers that you see here, anything beyond this whisker are going to be classified as outliers. So these points that you see here are your outliers here. All right, so these are outliers. So you have to come up with something to remove these outliers or to handle these outliers. By just looking at our data set, right, we were not able to identify or tell whether there is some outlier in our data or not. But yeah, when you use this visualization, when we plot this box plot, now we know that there are some outliers. All right, so this is your univariate analysis. Now let's move forward and look at the bivariate analysis. All right, so let's move forward. Bivariate analysis. All right, All right, so let's move forward. And here let's get some questions so that we can solve that using this bivariate analysis. Let's get back to our data, right? So this is our data set. We have checked this. What are the count of survived and not survived? So more number of people have died that were aboard this Titanic, and less people have survived this disaster. All right, now you want to know with respect to this sex. All right, with respect to this sex, what is the count of this people getting survived and not surviving? All right, so the one way you can use it, you can use this pandas, right? You can try to group by or use pivot table or cross tab and get this information, right? So I'm going to show you that how you do that. So here what you can do is you can write pd dot cross tab, all right, and here you can give this as your data dot survived comma data dot sex, right? And if you run this, here you get this table, right? So here you have this sex, that is male and female. These are your columns, and these survived are your index here, all right? And you can get this count, all right? So here if you see, the people that have died and were female are 81, and the male, in the count of male is 468. So more number of males have died and as compared to female here, right? So more male passenger has died, and here if you see whether who has the more chance of survival. So here if you see, out of this total, that is 233 plus 81, total 23 females have survived. So less number of female have died here, right? More number of people, female, has survived. And here if you see, more number of male passenger has died and very few have survived given their presence or in this disaster on aboard this Titanic, right? So if you are a female, there is a more chance of survival. So here you have to read about all this text, right? You have to read about this sex, male, female, survived, 0, 1, what does it means? And if you take it to someone who is not aware about all this technicality, then he might get confused, right? So better way to do the same analysis will be by using the graphs, all right? So here let's say I want to plot a graph. How do I do that? To do that, I can write SNS dot count plot, and here I can give data, all right, and here I'm going to give this survived, all right, and there are many other parameters or arguments that we can specify to get this done visually, all right? So here if you see, there are so many things that we can use this SNS dot count plot. There are so many arguments. You have X, Y, then you have hue, then you have data, then order, hue order, orient, color, palette, saturation, and if you go down, you will have the documentation and examples as well, all right? So here I'm going to add this hue here. So hue equals to data, and here I'm going to give this sex, all right? And now if I run this, let's run it. By default, if you see, it has formed this graph here, and here you get this legends as well, all right? And here on this x-axis we have this survived, that is 0, 1, right? So you have this survived 0 and 1, and you have this sex that is being colored, that is male and female. So here blue one represent your male and the orange color represent your female here, right? So here you can compare that easily. So here if you see the survived class, that is 0, and if you check here, this less number of female has died as compared to male here, right? And here if you see the survived class, that is 1, here you can see that more number of female has survived, right, and less number of male has survived, right? So you can do that visually, and now if you take it to someone, he will be able to tell you that, right, by just looking at this graph here only. All you have to do it, you have to add all the necessary information here. So you can add the title, you have to add the legends. If you see by default this comes with Seaborn, all right. So you have, this is your bivariate analysis, where we are doing this analysis based on these two features, that is survived and this sex, that is male or female. Similarly, you can do this for other variables as well. Let's say this time you want to analyze, all right. So I'm going to copy this code, go down, paste it over here. Let's go down, all right. And here let's say I give this survived, and now I want to check the P class. With respect to this P class, what is the chance of this survival? If I am going through this passenger class 1, do I have more chance of survival? If I am traveling through passenger class 3, there is less chance of survival. So we can give here Q equals to data P class. Alright, so here if you see here, we have this survived on our x-axis, and on our y-axis we have counts, and here if you see this time we have this 3 colors. So blue one represent your class 1, and this orange color represent your passenger class 2, and this third or the green one represent your passenger class 3. And if you see here, the more number of people that has died, that is 0, are from passenger class 3, right? So they are from passenger class 3 here. And if you see, the more number of people that has survived are from passenger class 1. So they might have more money, they might have paid for some boat or something, bribed someone, and then they might have saved their life. These are the chances, right? So you have to write your conclusion after this. I'm not doing that. I'm telling you that you have to write your conclusions as well, what you can conclude from this graph. So this is your bivariate analysis here. So we have seen univariate, we have seen bivariate. Now let's say I have a numerical feature, right? So we have numeric feature. Now how do we compare them? How do we do bivariate analysis? So for them you can use scatter plot, we can use multiple box plots, or you can use this multiple histograms as well. You have joint plots. So I'm going to talk about this with respect to, let's say, age. So let's get some new code cells. All right, so here let's say I write SNS dot box plot, all right, and here I'm going to give x equals to survived. So on x-axis we have this survived, and on y-axis I want to check the distribution of this age, all right, for those who have survived and those who have not survived. I want to check the distribution of their age. So y equals to, we are going to give here age and comma this data. So data means from where this data we are using. So data equals to data, all right. And now if you run this, let's run it, you get this 2 box plot here, right? So here you have this 2 box plot, and here if you see, this is the class, this is the survived class that is in color, orange color, and this is in the blue that you have this, the people that have not survived. All right, and here you can conclude by looking at this graph that both have some outliers, right? So here if you see the age distribution, your data is here skewed as well, right? But you don't have this outlier on this lower age, right? So those who are saved, if you see this, compare this two, if you compare these two and their age, then if you see here, those who have survived are of mostly between age group, let's say this 20 to 35, right? And here if you see, few of the outliers are there, that means they were old age people and they survived, so these are the outliers. All right, so we have identified these outliers using this box plot as well, right? Now let's say if you want to analyze this scatter plot, so if there is any kind of relationship between your age and your pair, all right? So here to do that you can write SNS dot scatter plot, right? So it's scatter plot, and here you can give x equals to your age and your y equals to your pair, and this data is coming from, so data equals to data. And now if you run this, here you'll be able to see the if there is any kind of relation or not. All right, so here so here as you can see there is no such pattern between this pair and age, right? So you can use this, and also let's talk about this multivariate data analysis now. So we have seen this univariate, bivariate. Now let's talk about multivariate. So to check the correlation, you can also check that using data.cor, and if you run it, you're going to get the correlation between all these variables. But it will be better to use the heat maps here. All right, so we are going to talk about that. So we are going to talk about the multivariate data analysis now. All right, so let's talk about this multivariate data analysis. So in multivariate we use more than two variables, right? So if there is more than two variables, we say that this is a multivariate analysis. All right, so here let's frame some question so that we can analyze. So here if you go up, all right, let's go down low. All right, so here we have seen this box plot, right? We have seen this box plot here, and now I'm going to copy it, go down, and I'm going to add another variable for our study in this box plot here. All right, so we have survived on x-axis, on y-axis we have the age, and also I want to check this with respect to, let's say, not age, this not serve, and with respect to another variable, let's say our p class, or let's say sex here. All right, so here I can run this, and if I run this here, I'm going to have the 3 box plot. So you have to specify here hue equals to now run it. Okay, we have given double E, it should be single. All right, now you have this multiple box plot here, right? So you have multiple box plot, and here if you see it, here it says the sex here, the blue one that you see, the box plot in blue color is for male, and the box plot in this orange color is for female here. All right, and here on x-axis we have this. On x-axis we have this survived and not survived, that is class 0 and class 1, and on y-axis we have the age. So we have added this 3 features here, right? And by using these colors and this axis, we are trying to analyze this data here. That is, we have survived. Then if you see here, let's understand it one by one. All right, so here let's say we are looking for this not survived, those who have not survived. All right, and you are looking at this age distribution here. All right, so you have age here, and here if you see, these are females, right? And if you see, this is for female, and those who have died, this is for not survived, that means they have died. This is for died, and this is color reflects that they were female. So those who have died are between age group this 30 to 18, and here if you see, this is the median age group in your male, right? And here if you see, there are some outliers as well for this males and females, and your survival, that is 0 and 1. Similarly, you can analyze this here as well, right? And here, if let's say if you want to add another variable, you can do that as well. And here I'm going to talk about something called as Boolean plot. So if you write SNS dot Boolean plot, and here if you give this, so I'm going to copy this from up here, go down, I'm going to paste it. All right, and here let's say age and 6, let's remove this hue for now, and if you run this, not box plot this time, we want the Boolean plot, you'll be able to see it more clearly. So let's run it. All right, so this is your Boolean plot. Here you can check the distribution as well. So here if you see, you have this distribution of your data for this survived and not survived class. All right, so you can check the distribution using the box plot. We were not getting that much of information, right? We were not able to get the clear idea of the distribution, but using this Boolean plot, you can check the distribution, and if you see inside this Boolean plot, you have this boxes as well. These are your box plot, and also you have much better idea of your classes. Let's say here if you add this hue, so hue equals to your comma 6, let's run it, and also we can give here, that is, just a second, yeah, here also what we can do is we can add this split equals to false. All right, now let's run it. So it is splitting. All right, so now you can better visualize it and also check the distribution here using this Boolean plot, right? So let's change it, it's split, not split. All right, so we have done this multivariate analysis here. Now let's say if you want to check the correlation of variables with one another. So here I have told you that data dot cor gives you the correlation, but it gives you a table here, right? So it gives you a table. So here you have this horizontal axis, this diagonal is always going to be 1 only. So here this diagonal is always going to be 1. Why? Because here if you check, survival is always correlated with this same class. We have survival correlated with survival, it is always going to be 1. P class correlated with this P class, it is always going to be 1. And here what better option is, you can use this heat map. All right, so SNS dot heat map, and here you give this data dot core. All right, and if you run it now, here you are getting this heat map. Let's say you also want to see the values. All right, so here by using this color coding we can identify them, but I also want to see the strength of this correlation. All right, so I also want to know the values here. So here I can give value underscore here we have to give this outside this box, and here you can give value this should be a note equals to true, and if you run it now you are able to get this information as well. And here you can see what are the variables which are highly correlated with each other. First of all, let's see which variable are mostly correlated with this survived class. So here if you see this survived class, and now if you see this minus 0.34, so there is a negative correlation with respect to this P class. Then there are very few, these variables are not that strongly correlated with this survived class. All right, now let's talk about this P class. So here we have this P class, and this P class is correlated with this survived, and the strength of this correlation is minus 0.34. that means there is a negative correlation. All right, also if you see this P class is correlated with the age here. All right, and if you see this P class is also correlated with this pair, and here if you see it is minus 0.55, so it is highly correlated with this pair here, this P class, and that is true, right? So here this P class is your passenger class, and it is going to be highly correlated with the fare, right? So if you have high fare, then that means you are having this higher P class, that means first class ticket. So if you go for first class ticket, it is always going to be charge you more, right? You are always going to be charged more. And here you can analyze this correlation within all other variables with each other. So this is your heat map. Now let's summarize what we have done today. All right, so first of all, we understood what data analysis is, why we do data analysis, right? We remove the anomalies, we have identified the outliers in our data, right? We have checked that what is the count which has the more chance of survival, male or female, and we have checked who has the more chance of survival with respect to P class. Now based on this exploration you can form your hypothesis, right? So you form your hypothesis that those who are in P class 1 have more chance of survival. So this is going to be your hypothesis, and those who are female have more chance of survival. These all are your hypothesis, initial hypothesis after exploring this data. After exploring, you have to go for your hypothesis testing, and you have to test your assumptions as well. So we have explored only, now you have to go for hypothesis testing. You can form your hypothesis much better and you can test your result now. All right, so we have formed this hypothesis. You can use t-test. There are different kind of hypothesis testing. You have to study that. You have to know the mathematics, descriptive as well as inferential statistics. right? So we have seen this univariate, bivariate analysis. We have talked how to prepare this mind maps, right? We have talked how to prepare this data dictionary over here. So these all steps are going to help you build your model, and this is going to save you a lot of time, all right, and resources, and your headaches as well. All right, so this is the exploratory data analysis, and these files are going to be available to you. Don't worry about that. If you have any doubt, you can ask that, and I request everyone that is present to join our Facebook group. We will have very informative session interactions with the experts over there, and you are going to learn from that group. It's not something that you have joined and we share this fun stuffs and memes and all. No, you are going to learn from that group in a fun way. All right, so please subscribe this channel. We are going to come up with other many webinars on different topics. So subscribe this channel and stay tuned. If you have any Alright guys, so anyone, if you have any doubt, please ask your doubt, and please subscribe to our channel, and also please join the Facebook group. We are going to learn from many things from that group. We are coming up with many interesting things for you guys, and it is going to help you for sure. All right, so thank you so much everyone, and thank you so much. Have a great day.